şirketlerin geleceğine ışık tutan teknolojileri uzmanlığımızla pekiştirerek sizlere sunuyoruz. Bugünkü konu da bunlardan bir tanesi. Özellikle son birkaç yıldır reusability İngilizce kavramı ama karşılığını yeniden kullanım diye tercüme etsek doğru olur zannediyorum. Birçok yerde, birçok sektörde yeniden kullanımı teşvik eden ve buradaki elde edilebilecek faydaları ön plana çıkaran bir takım çözümler sunuluyor. Biz işi mühendislik tarafından ele alıyoruz. Mühendisliği de tanım olarak oluşturduğumuz geometriler anlamlı hale getirdiği için aslında sürecin yani bir fikrin başladığı yerden bu çözümü de entegre ediyoruz diyelim. Yani göreceksiniz az sonra canlı uygulamalarla bir geometri oluşmaya başladığı andan itibaren footprint dediğimiz bir uygulamayla sistem içeride yani Winchill database'inde mevcut olan benzer parçaları belirli oranları da sizlere göstererek kullanıcıyı uyarabiliyor. Yeniden kullanımın arttırılması başta tasarımcının iş yükünü azalttığı gibi aynı zamanda organizasyonun farklı departmanları üzerindeki baskıyı da azaltabiliyor ve organizasyonel bir fayda ortaya çıkarabiliyor. Yani tipik olarak uygulamaları, yazılımlar bireysel ve kurumsal olarak ikiye ayırırsak kişisel yorumu ModelSearch her ikisine de hitap ediyor. Yani bireysel olarak ben bir mühendislik çalışması yaparken benzer parça var mı database'de? Öncelikle bunu gösteriyor. Niteliksel olarak bir miktar tasarımcı sayısının yoğun ve database'in de dijital arşivin de geniş olduğu yerlerde çok muazzam sonuçlar elde edebiliyorsunuz. Birincisi bu bireysel fayda. İkincisi de kurumsal fayda. Sadece tasarım bölümüyle yani Ar-Ge'nin kullanabileceği bir tool değil bu. Örnek vermek gerekirse satın almadaki bir arkadaşımız herhangi bir modele gidip daha önce buna benzer bir parça var mı? Varsa en son satın alma rakamı ne? Çünkü gün içerisinde satın almadaki arkadaşlar bir parça için farklı tedarikçilerden fiyat alıyorlar. Fakat belki benzer parçayı 6 ay önce almıştı, temin etmişti. Unutabilir en son alım fiyatını. Daha rekabetçi fiyatları somut örneklerle ön plana çıkarabilir. Ya da üretimdeki bir arkadaşımız daha önce oluşturulmuş bir takım yolunu benzer parça için yapılmış CAM datasını kalıp, akvarat, fikstür gibi tamamlayıcı unsurları üretimden gelen bir parça üzerinden tekrar kullanılabilir. İşletmelerin birçoğunda göz önünde durulan faktörlerden bir tanesi de envanterdeki, stoktaki parça sayısını azaltmak. Fakat bunun en başta bir domino taşı efekti yaratan yani farklı kodda aynı parçayı oluşturan bir yapıda bunu engellemenin ne yazık ki çok da bir metodolojisi yok. Yani ben bir parçaya yeni bir kod verdiğim an parça istediği kadar daha önce yapılmış olsun. Maalesef buna kimse dur diyemiyor. Çok tecrübeli arkadaşlarımız zihinlerinde tecrübelerinden kaynaklanan bir sonuç doğal olarak da bu. Uyarabiliyorlar. Daha önce şöyle bir şey yapmıştık. Buna benzer bir parçayı işlemiştik diyorlar. Fakat bu bir istisna. Bunun olmadığı durumlar çok daha yaygın. Dolayısıyla bir parçayı farklı kodla sisteme tanıttıktan sonra o domino taşları devrilmeye başlıyor. Artık satın alması da, tedariği de, deposu da, giriş kalite kontrolü de hiç kimse bunun farkında değil ve günün sonunda şöyle bir tablo ortaya çıkıyor. Rafta, depoda aynı parça her şeyle aynı fakat kodları farklı üst üste duruyorlar. Dolayısıyla buradaki elde edebilecek sonuçlar işletmelerin organizasyonel olarak da hızlanmalarını özellikle bu dönem tasarruf dönemindeyiz. Lüzumsuz parçaları, ikiz dataları azaltarak çok hızlı sonuçlar verebilmesi de programın diğer bir avantajı. Sizlere gerek zaman gerekse maliyet avantajı elde etmenizi sağlayacak. Tek tek bunları saymak istemiyorum ama uygulama iki şekilde çalışıyor. Bir Creo'nun içerisinde Live Search dediğimiz bir mekanizması var. Yani siz tasarım yaparken ya da ekranda da var bakın bir montajın içerisinde parça aktif halde bir parçayı activate ettiğinizde uygulama indekslemiş olduğu, daha önceden indekslemiş olduğu geometrilerden bir benzeşme oranıyla size bu parçaları veriyor. Ya da ikinci kısım çalışma prensibi de datayı Winchill'e check-in yaptıktan sonra Winchill üzerinde Find similar models dediğinizde sistem seçilmiş olan modele benzer dataları database'inden çok hızlı bir şekilde tarayıp sizlere gösterebiliyor. Datanın formatı çok sorulan bir soru olduğu için söylemek gerekiyor. Sadece Creo olmak zorunda değil. Yani Katya'dan check-in yapılmış, NX'ten, Inventor'dan, SolidWorks'tan. Yani kısaca Winchill'in entegre olabildiği bütün CAD yazılımlarından gelen dataları sistem analizini yapabiliyor. Bu da çok güzel bir kabiliyet esasen. Datayı dönüştürmenize gerek yok. Native data yani Katya'nın CAD partı, SolidWorks'un SLD PRT'si ya da Creo'nun PRT'sini sistem alıp analiz edebiliyor. İlave bir yatırımı da yok. Yani tabii ki ModelSearch'ün ilave bir lisans ihtiyacı var ama third party bir adaptöre, ne bileyim datayı convert etmemiz gereken bir yazılıma ihtiyacımız da yok. Diyelim ben burada nokta koyayım ama sorular olursa tabii ki buradayız. Sunum esnasında, sunumdan sonra bizlere erişebilirsiniz. Bugün sizler için buradayız. Dolayısıyla konunun iyi anlaşılması birinci prensibimiz. Burada ben teşekkür ediyorum. Sorular olursa tekrar katılırım. Philip, you can start your presentation. I finished my part.
Okay, perfect. So thank you very much. If
Thank
you
you.
assign me presenter, I can share my screen and
Okay.
then I can take it from there.
Vahap will do, I'm sure. Vahap yaptığında belirtirsin. Philip ekranı paylaşacak.
Okay, perfect. Thank you very much. I can share my screen, so everybody should see my screen now.
Yes, we can see your
Yes.
screen.
Okay, perfect. And then, yeah, we can start it from here. So thank you very much for the introduction, Serkan. As Serkan mentioned, my name is Philipp Hinterdorfer. I'm product manager for ModelSearch in Made at Austria. So ModelSearch is a geometric similarity search solution. So that means with only geometric information, we do have the possibility to find similar or identical models. Why have we developed a tool like ModelSearch? So I want to start really at the beginning with the motivation why we have developed that tool. And we have developed it because we talked to our customers and they had several challenges. So we talked to designers in the engineering department and they all told us that they do not find similar models. So they know that they have created a similar model in the past, but they don't know the article number. And because they do not know the article number, they do not find the model in the database. So what happens is they recreate the 3D model, but they do not only recreate the 3D model, they also recreate the drawing. They have to select the material, the strains calculation is redeveloped, and so on and so on. So everything that is attached to the model is recreated from scratch because they do not find the similar already existing model in the database. And the interesting thing was that exactly the same request came from other departments in the company. So we also talked to people in the workshop and they told us exactly the same. They know they have created a manufacturing NC program for a similar part in the past, but as they do not know the article number of the model, they do not find it in the system, and therefore they have to recreate the NC program. They know there is already one in their database, which they could probably reuse or at least partially reuse. But without finding it in the database, they cannot reuse, so they have to recreate it from scratch. And in the purchasing department, we had exactly the same request. So they also told us they know they had ordered a similar model in the past, but without knowing the article number, they do not find it. So that's why they have to start with the supplier selection again from the beginning. They have to figure out which supplier can manufacture the model, and then they have to figure out if the price from the proposal is okay or not. If they would have already existing proposals or already existing suppliers, then it would be way easier for them. And I can continue stories from different departments for the next 5 minutes. So the message is, wherever you can reuse existing data, a similarity search makes sense. Of course, those challenges also have some side effects. So let's focus on the design department. What does it mean if you do not find existing models? And what does it mean if you have to recreate them from scratch over and over again? First of all, as you recreate everything, you will create lots of models in your database. So there definitely is an explosive proliferation of parts and assemblies in your database. Most of the time, the models do not stay in the design department. They will find their way into production, which means you will produce lots of many similar or even worse, identical parts. And as you have to recreate all documents for every part in each department, this will lead to excessively rising costs in all those departments, like in development, because they have to recreate the model, in purchasing, because they have to re-evaluate the supplier, in production, because you have to recreate the NC program, in warehousing, because probably you have 5 times exactly the same model on stock, but on a different location, and in maintenance, because you're recreating the maintenance instruction over and over again. So when we install Model Search at our customers, then we always analyze their database. And we figured out that typically mechanical engineering companies, they all have several 100,000 models up to multiple millions, depending on if it is a small, a medium, or a bigger customer. And all of them, no matter how many models they have in their database, they have around about 15% unwanted duplicates. So around about 15% unwanted geometrical identical models. In 2016, VDMA, that's a mechanical engineering organization in Germany, they made a study and they figured out that for a company, the average cost of a purchase part are around about 1,800 euro, and the average cost of an in-house manufactured part are around about 3,400 euro. So if we combine the price with the 15% unwanted, unnecessary duplicates, then we can imagine the big saving potential we have if we would have the possibility to prevent those duplicates from being designed. Which possibilities do we have to prevent duplicates from being created? Well, which possibilities do we have to identify geometric similar models? Well, basically, there are two. First one is a manual classification, which you might already know. I've created a screenshot of a sheet metal part, and first of all, we can try to describe that part with the naming. So you can call it lash, angel, console, sheet metal, mounting bracket, whatever. So you see, for that simple part, I already have 5 terms. So if you call it sheet metal and I search in your database with mounting bracket, I will not find it because the naming is a different one. But if you search in your database for mounting bracket, then I'm quite sure you will find lots of models. But the results vary in shape and size. So only the naming is too less. You need additional information, additional geometric information, like the thickness, the number of slots, the length, the material, the width, the band radius, the hole pattern distance, or the slot dimension. So you already see, for that simple model, you have lots of work to do to have the possibility to find that model later on. And then, of course, each time you change the model, you have to update the attributes, because otherwise you find a model that has different criteria. So nobody has updated them. That's why manual classification is outdated. It does not really make sense. It's too much work. Way easier and way better is an automatic support. And that's what Model Search can do for you. So let me show you a screenshot. This is, let's call it a mounting bracket. And I'm now jumping into the role of the designer. And my task is to create that mounting bracket. So as I'm used to query parametric, I directly jump into where I start with the design. So I have selected a plane and I start with the creation of the first feature. I'm in the sketch. I draw a rectangle. I change the dimensions. I finish the creation of the sketch. I define the height of the feature, and then I finish the creation of the first feature. I directly jump into the second sketch, where I once again draw a rectangle. I create the mirror to the bottom, and then I will define some dimensions. So I'm interested in the distance of those as well as of those outside lines. Then I'm also interested in the length of the rectangle. I'm done with the sketch, so I finish the creation of the sketch. I define the height of the mounting bracket, and then I finish the creation of the feature. And as you can see in the lower right corner, each time when I finish the creation of a feature, the model is regenerated, the so-called footprint is created, a similarity search is started, and Model Search Live appears automatically in the lower right corner, showing me similar models that are already available in my database. So during the presentation, I was a bit too slow. That's why it automatically disappeared. But it's nice to see. It automatically appears and it automatically disappears. So if you're not interested in the results because there is nothing similar in your database, then just ignore it. It's hidden automatically. In my case, I want to show you the results again. That's why I regenerate the model. Footprint is calculated, similarity search is started, and as you can see in the lower right corner, Model Search Live appears again. Of course, Model Search does not only work with easy created models, it also works with more complicated ones, like that molded part. So I regenerate the model, footprint is created, similarity search is started, and as you can see in the lower right corner, Model Search Live appears. Of course, it also works with a milled model. We generate the model, footprint is created, similarity search is started, and once again, in the lower right corner, Model Search Live appears. It also works with assemblies. So let me regenerate the model. Same procedure happens. In the lower right corner, Model Search Live appears, showing me similar assemblies. And of course, it also works with sheet metal models. So as you can see, no matter how the model is designed, so is it a solid model, a turned model, a milled model, a sheet metal model, or an assembly, you can, with Model Search, search for similar models. There is more that I can show you. So it does not only work with parametric models, it also works with multi-CAD models like CATIA, Inventor, SolidWorks, or NX, but also with non-native parametric files, like in my case, a step file. So I import it to Creo, the geometry is regenerated, the footprint is created, a similarity search got started, and once again, as you could see in the lower right corner, Model Search Live appeared, showing me similar models that are already available in my database. So as we now know that we do have the possibility to search for similar models, I guess we can talk about the next step. Let's analyze the results. So in that case, I move the mouse over the preview, which fixes the result dialog to the foreground, meaning I have more time to analyze the result. In my case, I have found 7 models which are similar to the sheet metal model I have designed. As you can see, there are preview images in the result dialog, but I also have some attributes, like in my case, the name, so the file name, the life cycle, and the bounding box, so the main dimensions. In the lower left corner of the preview image, I have the file type. So I'm not working in a parametric environment only. I also have NX files, SolidWorks files, Inventor files, and CATIA files. That's why the icons differ. And in the lower right corner, you can see the similarity weighting. So the higher the similarity weighting, the more similar the models are. We also use the similarity weighting to order the results, meaning the results on the left side are more similar than the ones on the right. And as you can see, we also use the similarity weighting to highlight the models. So the first 5, they have a similarity weighting higher than 90. That's why the background color is green. The other one have a similarity weighting between 80 and 90. The background color is blue, and there are multiple opportunities. Let's talk about the attributes that you can see here. Those attributes are also customizable, so you can use attributes which are designated from the CAD system to Windchill. You can use attributes that are only available in Windchill, so-called IBAs. And we can also show attributes from a third-party database system, like ERP as example. If you move the mouse over the small preview icon, you will get a bigger one with additional attributes. So in my case, there is only a fourth one available called customer, and as you can see, I have not filled that one for those sheet metal models. That's why it tells me not available. So I told you we want to start to analyze the models. So what's easier than opening them into Creo Parametric and starting to analyze them there? You all already know how Creo works, so open them directly into your Creo Parametric session. Then you can analyze them. You can add cross sections, you can start measurements, you can zoom in, you can rotate. So I guess that's absolutely the easiest way. In my case, I have found 5, 6, 7 models which are very similar, and for that reason I have the possibility to load them all into one assembly, because then it's easier for me to figure out the differences between the results. Otherwise, I have to jump from one window to the next one. Sometimes I do need additional information. Additional information that's probably not available in Creo, but that's available in Windchill, like does the drawing already exist? Does the NC program already exist? And as Model Search is directly integrated in Creo and Windchill, we can once again directly from the result dialog jump to the model's information page. And then there is one last thing that I can show you. It's called compare model. So this one is really identifying the best position, and when the algorithm has found the best position, then you will receive an assembly where the models are located. To better understand, we only search with geometric information like amounts of surfaces, biggest outside diameter, smallest outside diameter, ratio of moments of inertia. So really only geometric information. We don't care about how the model is created or where the model is located. So I mean, let's imagine you are creating a shaft. First designer is creating the shaft in x-axis, second one in y-axis, third one in z-axis. It doesn't matter at all. We don't know how the model is located. So it can also happen, first designer is starting directly in the coordinate system. Second one is starting 100 millimeter to the right of the coordinate system. It doesn't matter at all. We don't care. We don't know where the model is located. We only care about the geometric entities, and they are always the same. So when talking about the result dialog, you can see that the two models are assembled. They are also painted. One is painted red, the other one is painted green. So this means if you only see red surfaces, or like in that area, if you only see green surfaces, then they are available on one part only. If you see shaded surfaces like in that area, or orange or brown one, then it means the surfaces are available in both models. Of course, this at this time is only an analysis for outside geometry. But as you can see in the assembly, you have three cross sections, one in X, one in Y, one in Z. So with that, you can also analyze inside geometry. And again, it's a native queer parametric assembly. So you can add additional cross sections, or you can change existing ones. And then maybe you saw it already in the model tree. There are two additional models, and those are the so-called difference models. So this one is created the following way. We copy geometry of the first model, of the red one, and then we subtract geometry of the green one. So red minus green, in my case, stays empty as the green one is bigger than the red, obviously. The second one is created the other way around. So this means what you can see right here is the difference between the two models. And with that information, the designer definitely can make his decision. Can he reuse the already existing model with all the downstreaming stuff like drawing, material selection, strength calculation, and C program? So can he reuse all that stuff directly? Or if not, he can reuse it as a template. So open it, create a copy, make those minor changes, and again, copy all the downstreaming stuff, drawing and C program, and so on and so on. The good thing with model search is it's not restricted to the design department only. As I told you in the beginning, also other parts of the company need to reuse existing information. So let's imagine I'm in the work floor now and I have to manufacture a model. I have to manufacture that model. I remember I have created a similar mold in the past, but I cannot remember the article number. So with model search, that's absolutely no problem. Just start the similarity search in Windchill. You are forwarded to the model search tab. You are forwarded to the result dialog. And as you can see, models are sorted with a decreasing similarity rating, similar than before in Creo. You also have a preview. So this is the model I started the search with. And then you can see the first two are identical. This one has a similarity rating of 97, and then it decreases. So they are also similar, but there are some minor changes. From the similarity rating only, of course, I do not know what is the difference. But once more, I can start analyzing with, as example, the main dimensions. And then in that case, you can see, okay, this one is a millimeter smaller than the one I started the search with. Of course, you can also open them in Creo, in Creo View, or compare the drawings, whatever is necessary to figure out if you can reuse the model. As I showed you before in Creo, of course, it also works in Windchill with assemblies. So just navigate to an assembly, start the similarity search, you are forwarded to the result dialog, and as you can see, I found 3 assemblies which are similar. The first one is the one I started the search with, and then those are the similar ones. When talking about assemblies, then we have more possibilities. As you can see, we also have the possibility to run an assembly analysis. What does this mean? Well, on the first view, it only shows me the structure of that assembly. By running the assembly analysis, I start the similarity search for every model in that assembly. And here is the result already. You may wonder why there are less objects available than before. That's easily explained because I'm working with a threshold and I'm only interested in models where I have a similar one with a similarity weighting higher than 90%. So this means all the other ones had a similarity rating smaller than 90. That's why they are not shown anymore. So these are the models I'm interested in. And as you can see, I already have a model that is geometrically identical than the one I have created in that assembly. So as I'm interested in the model, I start the similarity search, which brings me another table at the bottom. And there it shows me the geometric identical model. So those gear wheels are absolutely the same geometrically. The only difference is the article number. So if I haven't released the assembly, I would replace this model by the one that already exists. So I do not create duplicates in my database. We can continue with the next one like that. So I found a model with a similarity rating of 97. How does it look like? So I can once more start the similarity search. The table below updates, and as you can see, this is the similar model from my database. But there are 2 things left I wanna show you, and the next thing is the so-called parameter search. For the parameter search, let me rearrange my windows so it's a bit easier for you to follow. I jump into the parameter search and then I start from scratch. Once again, my use case is I'm a designer and I need that mounting bracket for my assembly. I know I have created a similar one in the past, or I know there is one in the database, but I don't know the article number. How can I search for it? Well, first possibility I showed you, start Creo, start your design, and then with the help of Model Search Live, the model will appear in the lower right corner. But you can also search for that model without starting the design, because you can describe it with geometric entities. You know at least approximately the length, the width, and the height. And then you probably know there is a hole with a diameter of 25, and there are 2 additional holes with a diameter of 5 and the hole pattern distance of 40. And with that information, you can try to start a search. You can try to start a parameter search. So the bounding box is the smallest cube the model fits into, and a cube always has 3 dimensions, length, width, and height. And the biggest one is the max, so in my case 90. I do not search with equals 90 alone, because maybe the model in my database has a length of 89 or 91. Then I can also reuse it, because I don't mind if it's a bit bigger or a bit smaller. Therefore, the max 90 plus minus 10, the med 90 plus minus 10, the min 70 plus minus 10. So I start the search and forward it to the result dialog, and in my case I found 81 objects. Well, now we can discuss, do we search through 81 objects? It depends. I would say 81 out of 100,000 is not too bad, but if you don't search through 81 objects, then go back, add additional criteria like the drilling diameter 25 plus minus 5. I could nail it down from 81 to 9 objects. And when we check out the previews, then I think you all agree with me. They look at least similar than the model on the right side. The only task I have is figuring out which one works the best for my use case. And the last thing I want to show you is the duplicates. So Model Search also creates a duplicate report from your database. So the only thing you have to do is jump into the Model Search tab, which is fully integrated in Windchill, select the Duplicates tab, and there you go. In my case, I have identified 203 duplicates. We show you, oh, I'm sorry, there are 324. So looks like, yeah, one node was not expanded. That's why it didn't count them. So in my case, there are 324 duplicate groups. And as you can see, there are 4 sub-tabs like visible, changed, invisible. By default, all duplicates are visible, so they all show the green light. I do have 324 visible duplicate groups, and they all receive a name from a part that's in that group, and in brackets it shows you, okay, there are 4 models in that group. How do the models look like? I can add a separate table below with once more the variables, some attributes, customizable, and the article number. So in that case, I do have 4 times that shape. The only difference is the article number. Here I do have 4 times that clip. In that case, it's an assembly. The only difference is the article number. Then I do have 3 times that sheet metal part. Once again, the only difference is the article number. Let's jump back to the first. And then, as you can imagine, our customers want to get rid of duplicates. So they are trying to delete 3 from those 4 models from the database. In that case, probably it's possible because the model is not used in assemblies, but that's not the case very often. Most of the time, they are in use in assemblies, and then you have to replace the models, which ends up in lots of work. So most of our customers only change the life cycle from 3 models to obsolete. So everybody in the company knows, okay, I'm not allowed to reuse. And then the stock will resolve itself in some time. When they did so, they do not want to see the duplicate group in that tab because there was 323 left. Therefore, they can change the visibility, and as you can see, it's automatically hidden from the tab. So there are 323 left, and yeah, the group name disappeared. So this means the visibility has changed from green to red, and the model was, or the group was moved from the visible into the invisible duplicate group. So as you can see, here it is, and the traffic light has changed from green to red. Maybe you are asking yourself, why do we work with the traffic light symbol, or what is the third status, the yellow status? And that's also easy to explain. So let's imagine you have resolved that duplicate group, and then one designer is creating exactly the same model. Then ModelSearch will recognize it, because if you check in the model, it creates the footprint, it searches for duplicates, and it will identify, oh, there is a group with identical geometry, so it will add the new model to that group, meaning there are 5 models in that group now, and then it will automatically change the status from red to orange, as well as it will automatically move the group into the changed tab. If you like, we can also notify your administrator when that happens, so you can prevent that model from being released, meaning that model will never find its way into production or into the ERP system. All right, that's everything from my side for that time.
Very good.
Are there any questions, Serkan?
Thank you, Philip. Quite good presentation. Let me ask the audience. Sorusu olan var mı acaba? Mikrofonu açıp sorabilirsiniz. Sanırım yok. Okay, it seems no question, Philip.
Okay.
If we get any question or request after the meeting, we can ask your help. And thank you and hope to meet you soon in another meeting.
Perfect. Thank you very much. Have a great day and see you. Bye.
Thank you.
Thank you very much.
Thank you. Bye bye.
Thank you very much.
Görüşmek üzere.
Thank you very
Çok
much.
teşekkür ederim bunlar için.
Tüm katılımcılarımıza teşekkür ederiz. Başka bir etkinlikte görüşmek dileğiyle.